Ever wondered how the electricity that powers our cities and industries gets to be so, well, powerful? A huge part of the answer lies in these green boxers you see everywhere, the three-phase transformers. Today, we're going to demystify these workhorses of the electrical grid. So, why do we even need three-phase power? Think of it like this. A single-phase system is like one person pushing a car. It works, but it's jerky. Three-phase is like three people pushing the car, each starting their push just after the other. It's a much smoother, more efficient, and more powerful delivery of energy. This is crucial for running large motors and heavy machinery in factories, commercial buildings, and hospitals. But how do we get from the super high voltage on the transmission lines down to something usable? That's the transformer's job. Let's look at how they're built. Inside a typical pole-mounted or pad-mounted transformer, you'll find three separate coils, or windings, wrapped around an iron core. One set of coils is the primary side, which connects to the high-voltage utility lines. The other is the secondary side, which provides the lower voltage to our buildings. The magic happens through electromagnetic induction. The alternating current in the primary coils creates a changing magnetic field in the core. This magnetic field then induces a current in the secondary coils. By changing the ratio of windings between the primary and secondary coils, we can step the voltage up or down. More windings on the secondary means higher voltage. Fewer windings mean lower voltage. Now, let's talk about those different voltages you hear about, like 480 volts, 277 voltios, 208 volt, and 120V. These come from how the secondary coils are connected, which leads us to Y and delta configurations. Imagine the three secondary coils. In a delta configuration, they're connected and forming a triangle shape, like the Greek letter delta. Measuring between any 2 points gives you a specific voltage, say 240 volts. This is great for powering three-phase motors, but what if you also need standard 120-volt power for lights and outlets? That's where the Y configuration comes in. In a Y setup, one end of each of the three coils is connected together at a central point, called the neutral. This looks like the letter Y. The voltage between any two of the outer phase wires is your higher three-phase voltage, like 208 volts. But the voltage from any phase wire to that central neutral point is lower in this case, 120 volts. It's incredibly versatile. A very common setup you'll see on a transformer nameplate is delta. This means the high voltage primary side is connected in a delta configuration, and the lower voltage secondary side is connected in a Y. This is often used to get 480 volts for machinery and 277 volts for lighting from the same transformer. There are also variations like high leg delta, where one of the delta coils is center tapped to create a neutral, giving you both 240 volts three-phase and 120 volts single-phase, but with one high leg that has a higher voltage to ground. An open delta, which uses only two transformers to provide three-phase power, saving costs, but with less capacity. From the giant generators of the power plant creating three distinct waves of electricity, to the transformers stepping it down and configuring it just right, the three-phase system is an engineering marvel that keeps our modern world running smoothly and efficiently. I hope this helps you look at those green boxers with a new appreciation. If you found this video helpful, please give it a thumbs up, and don't forget to subscribe for more deep dives into the technology that powers our lives. Thanks for watching.